Hey everyone, in this video we'll be solving systems of linear equations using elimination. So our first system is 2x minus 5y equals 5 and x minus 3y equals 4. So we're trying to combine these two equations together by either adding them or subtracting them so that one of the variables is eliminated. That will leave us with an equation with only a single variable, which we know how to solve. And then we can go back and find the variable that we eliminated to come up with our point. So the first decision we have to make is what variable are we going to eliminate? Well, looking at this particular system of equations, the x variable is going to be easier for us to eliminate. Right, I have a 2x here, so if I can make this term a negative 2x, if I add the two equations together, the x terms would be eliminated. If I wanted to eliminate the y terms, I would have to multiply both the first and the second equation by a constant in order to accomplish that. Not impossible, just an extra piece of work that we can avoid if we set it up to eliminate the x's. So we're going to start by multiplying this whole equation by negative 2. So we'd have 2x minus 5y equals 5, and negative 2x plus 6y equals negative 8. Now, the property that allows us to just multiply this whole equation by negative 2 is a property we talked about earlier, and that's the multiplication property of equality, right? That states that if we multiply one side of the equation by negative 2, as long as we multiply the other side of the equation by negative 2, we're not changing its solution. Still the same idea here applied to a system of equations. So now we're going to add these two equations together. So we would get 2x plus negative 2x, so that's 0x. Negative 5y plus 6y is plus 1y equals 5 plus negative 8 is negative 3. Now 0x is really just 0, so we'd be left with y equals negative 3. Now we're not done. That's only the y coordinate of our point. We need to find the x coordinate, and we'll do that by substituting negative 3 in for y. And in this case, let's use the second equation. So x minus 3 times negative 3 equals 4. So x plus 9 equals 4. Subtract 9 from both sides. X equals negative 5. So our solution is the ordered pair, negative 5, negative 3. And as always, when we're going to write the ordered pair, just pay attention to the order you're writing the values in. Right? It's a simple mistake to make. Right, just switching and writing negative 3, negative 5, but I see it happen. So let's define the steps to solve a system using elimination. So first things first, decide which variable to eliminate. So in that first example, we eliminated the x. Typically, one is easier than the other, but there are cases where it's an equal amount of work, so you just have to pick one variable over the other. Then you're going to multiply one or both equations by a constant so that adding or subtracting the equations will eliminate that variable. So in that first example, we multiply the second equation by negative 2. So that 2x and negative 2x eliminated. Then you're going to add or subtract the equations in order to eliminate that one variable and then solve for the remaining variable. So we did that. We were left with just a y term, so we didn't have much solving to do, but we were able to find the y coordinate. Then we took that, substituted it into one of the original equations. In the first example, we substituted it into the second equation. We then found x, and then we write our solution as an ordered pair. Next example, 4x equals 8y, 6x minus 4y equals 6. So if we're doing this using elimination, we want it so that the like terms are lined up. So we can subtract 8y from both sides. We would have 4x minus 8y equals 0, and 6x minus 4y equals 6. So now we have to make the choice as to what variable we want to eliminate. Well, here it's going to be much simpler to eliminate the y terms, right? If this is negative 8y, all I have to do is multiply the second equation by negative 2 so that it becomes a positive 8y, and the y terms will eliminate one another. If I wanted to eliminate the x's, the least common multiple of 4 and 6 would be 12. So we'd have to multiply the first equation by 3, the second equation by -2. Now, not much more difficult, but it's still more multiplication. So let's multiply this second equation by -2. We have 4x minus 8y equals 0. Negative 12x plus 8y equals -12. And just something I want to point out, don't forget about the constant value on the other side of the equal sign. Right? If we forget to multiply that by -2, we're going to come up with an incorrect answer. Now, we can still solve. It's not going to prevent us from solving, but we might wind up with some more difficult fractions that just take longer to work through, and we're going to get the wrong answer. So now we're going to add these two equations together. So 4x plus -12x is -8x. Negative 8y plus 8y is plus 0y. And then 0 plus -12 is -12. So this is really just -8x equals -12. Divide both sides by -8. In simplest terms, the negatives will simplify, and 12 and 8 can both be divided by 4. So this is going to be 3/2. Now we have to solve for the y-coordinate. So let's substitute into the first equation. I think it's just simpler. So 4 times 3/2 equals 8y. So we're going to get, so let's see, 4 divided by 2, so that's 2. So on the left side, we have 2 times 3, which is 6, equals 8y. Divide both sides by 8. 6 and 8 can both be divided by 2, so we have 3/4 equals y. So writing our solution as an ordered pair, it's the point 3/2, comma 3/4. And if we want to check that we're correct, we can substitute that into the second equation and see if it's a true statement. So we'd have 6 times 3/2, which is 9, and then 4 times 3/4 is 3. 9 minus 3 is in fact 6. So it does check out. Next up, 3x minus 1/2 y equals 10, and 5y minus 2x equals -16. So first thing to do is rewrite that second equation so our like terms are lined up. So 3x minus 1/2 y equals 10, and -2x plus 5y equals -16. Now we have to choose what variable we want to eliminate. Well, in this case, there's not an easier choice. Whether we're eliminating the x terms or the y terms, we're going to have to multiply both equations by a constant. So let's eliminate the x terms. So the least common multiple of 3 and 2 is 6. So we'll multiply the first equation by 2 and the second equation by 3. The signs are already opposites, so I don't need to multiply by a negative value. So we would have 6x minus y equals 20, negative 6x plus 15y equals -48. So now we're going to add these two equations together. So we're going to have 0x plus 14y equals -28, which is just 14y equals -28. Divide both sides by 14. Y equals -2. Now we're going to substitute that value into one of our two equations. So let's substitute it into the second equation. So 5 times -2 minus 2x equals -16. -10 minus 2x equals -16. Add 10 on both sides. -2x equals -6. Divide both sides by -2. And we have x equals +3. So our point is 3, -2, which is the solution to this system of equations. And if we want to check it, substitute into the first equation, we'd have 9 plus 1, which is in fact 10. Next example is 3x plus 7y equals 11, and 6x minus 22 equals -14y. So first thing is to rearrange that second equation so that all of our like terms are lined up. So we can do that by adding 22 to both sides, and at the same time I'll add 14y to both sides. So that's going to be 6x plus 14y equals 22. And most of you would probably do that in 2 steps, but just so we can get to the elimination more quickly. So we have 3x plus 7y equals 11, and 6x plus 14y equals 22. So looking at our x terms, if we can make this term a negative 6x, then we'd eliminate the x terms. So let's multiply that first equation by negative 2. So we'd have negative 6x minus 14y equals negative 22. And then positive 6x plus 14y equals 22. Now we can add these two equations together, and we would get 0x plus 0y equals 0, which 0x and 0y are really just 0. So 0 equals 0. Well, 0 always equals 0. So what does that mean? Well, that tells us that these two lines are the same line. If we were to graph them, they would look identical. So how did we write the solution when the lines were the same? We wrote the solution as all points on the line. So each of these represents the same line, so we choose one of them. So I'll choose the first one. So on 3x plus 7y equals 11. Okay. Now, what would this look like if the answer was no solution? Well, what would happen is we would get the same constants. We would still get 0x plus 0y on the left side, but on the right side of each equation, the constant would be different, so we wouldn't get 0 over here. So we might wind up with something like 0 equals 4, right? And that would indicate to us that the system has no solution, that the lines are parallel with different y-intercepts, okay, where here the line is the same. Our last example, 3/4 x plus 3/5 y equals 3/5, and 10x minus 2y equals negative 10. So we want to start by eliminating one of the variables. So let's eliminate let's eliminate x. Okay, so first thing, let's clear out these denominators. So let's multiply this by a factor of 20. Let's see what that would give us. So that's going to give us 15x plus 12y equals 12. And then we have 10x minus 2y equals negative 10. So actually, now that we did that, now that we eliminated the fraction in each term of that first equation, looking at the new system, I had originally chosen to eliminate x, but I think it's going to be simpler for us to eliminate y. So to eliminate y, all we have to do is multiply this second equation by 6. So we'd have 15x plus 12y equals 12. And 60x minus 12y equals negative 60. So adding those two equations together, we have 75x plus 0y equals negative 48. So 75x equals negative 48. Divide both sides by 75. X equals, so let's see, 48 and 75 are each divisible by 3. So that would be negative 16 over 25. And 16 and 25 don't have any common factors, so that is simplest terms. And now that we've solved for x, we have to go back and solve for y. So I'll substitute into the second equation. So 10 times negative 16 over 25 minus 2y equals negative 10. Let's fix that 0. Okay, so here 10 and 25 reduce, so it would be 2 and 5. So we have negative 32 over 5 minus 2y equals negative 10. We will add 32 over 5 to both sides. So we have negative 2y equals, so I need common denominator here, so this will be negative 50 over 5, which will give us negative 18 over 5. Multiply both sides by negative 1/2. So the 18 and the 2 simplify, 9. So that means that y equals negative 9 times negative 1 is positive 9 over 5. So our solution is negative 16 over 25 and 9/5. Okay, so that's how we solve a system of linear equations using elimination. You got to make the choice as to what variable to eliminate, and then go through the process, solve for that first variable, and then substitute into one of our equations to find the second. We also looked at an example where our solution was all points on a line, and we talked about what it would change to look like if it would have been no solution. Right? So now we've covered both algebraic ways to solve a system of linear equations. Now it's on to you to practice and get comfortable with both.